In this video, we're going to look at topic 76, example 4, solve a linear quadratic system of inequalities. So how can you solve this system of inequalities? And they give us the system y is less than negative 2x squared plus 12x minus 10, and 4x plus y is greater than 4. So you could do a lot of this by hand. I'm not going to. I'm going to use the graphing calculator. I just think it's far more practical for a problem like this rather than trying to graph this by hand, finding specific points. And really, ultimately, we're just going to get a sketch anyway. By hand, the graph is not going to be perfect. So let's make our lives a bit easier. Okay. Equation or inequality 1, we have y is less than negative 2x squared plus 12x minus 10. And what I'm going to do is I'm going to type that in the calculator right away. So negative 2x squared plus 12x minus 10. Now notice that our graph is not kind of the standard numbers. So if I go to graph this, we can kind of see this here. And this is what this is going to wind up looking like. So if I look at our window, I think we're okay right now. Yeah, so let's leave it there. And I will go back to the table, but right now let's do one at a time. So I'm going to go to y equals, and for my second equation, this red one here, I'm going to use the 4x plus y is greater than 4. However, we can't type this in the calculator in the form it's in. We do need to have the y value isolated. So this is going to be y is greater than negative 4x plus 4. So here we're going to type in negative 4x plus 4. Now we are going to use the calculator to get the graphing points to make our lives a little bit easier, but I will show you how to do the rest of this by hand, determining solid and dotted lines, which you need to know the graphing calculator won't do for you, and whether you should be shading above or below. Okay, so if I go back to our graph, it looks like we're going to have two solutions. However, one of them is not on our graph right now, so that is important that we figure out what to do with that. Okay, so let's take a look at our table. Or actually, you know what, let's go to Zoom and let's go down to ZFit. This one usually works well. We'll hit ZFit, and we have the two solutions, which that graph may or may not help us, but let's see what we can do with this. All right, so let's go to second table, and let's pick some points. We already have the graph here, so I know that I'm going to try and find points within a reasonable range. Let me go back to this real quick here. So I'm going to go to my table, and I know right away that, so I might have to scroll down by 5s. All right, the hundreds obviously are not going to work for me, so I'm going to go with negative 2, negative 42 is not on my graph, so negative 1, negative 24. So one of the points we'll look at is negative 1, negative 24, which again, we can't make this perfect, so we're just going to try and be as accurate as we can. 0, negative 10, that's an easy one. 1, 0, that's an easy one. Again, you do need to be pretty careful here with how you're plotting these. 2, 6, again, that's going to be somewhere here. I don't know exactly where, but close enough. 3, 8, 4, 6. All right, so I know I have my vertex is somewhere here. All right, it's going to change directions. 4, 6 of 5, 0, and then I can kind of start mirroring this now. It should be 6, 10, or 6, negative 10, sorry. And then negative 24, 7. So that'll be somewhere here. Now, this is by no means a perfectly drawn sketch, but we're going to have to work with it. Since y is only less than negative 2x squared plus 12x minus 10, we do need to make this a dotted line. And then that's going to be kind of as accurate as we're looking to get right now, because that's just what we're going to do. Not too bad. So let's kind of continue on from there. We have our the blue line, and again, I'll talk about the greater than less than where we're going to shade that in just a minute. Or you know what? Let's do it now. So we're going to shade this. We want values that are less than negative 2x squared. So less than in terms of this parabola would be anything that falls inside of our graph here. So you don't need to shade this yet. I would suggest not shading it, especially if you're only using a pencil. This is what this would look like. This is not our solution. This is just where the quadratic term is. So not my best shading, but we're okay. This is just a sketch anyway, right? So now let's look at our second equation. Again, we want to fall within the range of numbers that work. I don't really care about the numbers that are like way off. Maybe I'll go with -5, but that matches up with 24, which is going to be off my graph. So somewhere around 12, -1/8, that'll do. So that'll be somewhere around here. And then we'll just kind of build from there. 0, 4, 1, 0. Notice that that was also a point on the parabola. So we want to highlight that. 1, 0. We're going to write that on the bottom down here. 1, 0 is a shared point. Again, you want to make note of that as you're going if you can. It'll save you a little bit of time. 2, -4. So that's going to be somewhere here. And it's not going to work out too perfectly, but you get the idea. 3, -8. So 3, -8, somewhere here, I guess. 4, -12. Somewhere, oh, yeah, somewhere there. All right, 5, -16. That's going to be down here. Oh, that's not at all what we wanted to do. So 5, -16. Again, 6, -20. So that's going to be here. Still not our answer. 7, -24. I think we remember that one. All right, so notice that that's also a shared point. So 7, -24 was a shared point. Okay. Remember, shared points are our solutions. So when we're looking to solve this, that's kind of helps us a bit. I'm sorry, we're looking at inequalities here. If this was an equation, then those would be our answers, but this helps us. So now I'm going to connect these dots. Again, we want to use a dotted line though, because it's just y is greater than that number. So I'm just going to shade, I'm sorry, I'm going to draw this line here. This is probably the worst sketch I'm not going to say ever, but it's up there. We want values that are greater than -4x + 4. So those numbers are going to be to this top right portion. So they would be the numbers that are over here. Okay, all of these would be the solutions to the linear inequality, everything here. Okay, so all of this. So what is the question? How can you solve this system of inequalities? So the solution is where these two shaded regions overlap. All right, so I'm going to take away my shading. Hopefully you didn't shade like I suggested. You held off on that. But we have this shaded under, like kind of the inside underneath the quadratic and the top right for the linear. So the shaded region is going to be, I'm going to shade this as best I can. That's going to be this shared region in here. Okay, again, it's not going to be perfect, but we're going to kind of work with what we have. So that little area in there, that is the solution to our system. Not the easiest thing in the world. Definitely not a very user-friendly system. If you wanted to, and I purposely held off on this, if you go back to your y equals, and we change these to be, instead of looking like that, on the graphing calculators, you can kind of click this. We want less than for this one, so I would look for that symbol. So that's okay, we're going to stick with that. And then the red one here, we're going to again change that. We want greater than this time, so that's going to be the top right corner. So I'm going to hit OK on that. And now if I graph these, you'll see that shared region there. So you won't be able to see the entire shared region if you just use a standard window on your calculator. If you do zoom out, Again, it depends on kind of what you're zooming out with or how often. You might get something like that. There's going to be all variations on your zoom, so I'd recommend just kind of playing around with the calculator, figuring out what's the best window for you. A lot of times they give you the graph like they gave us here, so we knew kind of what range we should be looking in. But notice that our sketch, our terrible sketch here, does match up with what's on the calculator. We just can't see all of the shared points kind of in the window that we're looking at right now. But the idea is you're looking for where the two separate inequalities overlap. In this case, it's that pink shaded region. Hopefully that wasn't too torturous and you're okay with it.